Good afternoon, everyone. Thank you for joining our webinar today. Our today's topic is designing robust systems virtually with SIMULIA. So before I hand over to our technical speakers, I would like to give a brief introduction about our company, EDS Technologies. We are one of the largest technology solutions providers in India with more than 30 years of business transformation experience. We help transform businesses by enabling adoption of virtual twin, geospatial analytics, and 3D printing. We have introduced many technologies like 3D printing, VR, digital manufacturing, etc. for the first time to Indian customers. We have established ourselves as a trusted partner for more than 2,000 organizations across various industries, which includes automotive, aerospace, defense, industrial equipment, mining, and more. We have dedicated regional teams who are reinforced by our domain and functional consultants. We are backed by strategic alliances with global leaders who are pioneers in their respective technology areas. We have a widespread presence with 11 offices across India, and we are an end-to-end technology solutions providers to our customers. So our speakers for the day is Mr. Dr. Danish and Anand. So Dr. Danish has completed his PhD from IIST, specialized in the field of composites and has several Scopus indexed publications. He currently works as a senior manager for engineering simulation at EDS Technologies. He is using SIMULIA for the past 13 years and has more than 3 years of industry experience. He works with many composite manufacturers and research institutions to improve their existing design practices and methodologies. So our second speaker for the day is Mr. Anand Kumbhar. Anand specializes in multibody simulation with Simpack and finite element analysis with Abaqus solutions. He provides technical support and training to customers, helping them leverage these tools effectively for their engineering needs. Currently, he is working in EDS Technologies as Assistant Manager Technical. He has completed his post-graduation from Rajaram Bapu Institute of Technology, Maharashtra.
Thank you, Abhay. Good afternoon to all. So I'll keep the agenda short, but the presentation is a bit longer. So I'll try to finish it in a given time period. So I'll start with challenges. I have taken a case study based on a drone system, that is eVTOL. Based on that, what all challenges are there, how we can resolve those challenges, what all solutions we are having. I'm going to demonstrate that. And then specialized in composite design and simulation, how we can do composite design and simulation in a seamless environment. And of course, CFD applications as well as electromagnetic simulations, because these all things combine together to form a aircraft, or we can say an aerospace and defense structure. So moving towards challenges first. So as we all are from a different verticals, but we are focusing right now on specialized on aerospace and defense. So how we can get these challenges and come out of that? So first of all, we are moving towards the multidisciplinary simulation complexity, where we are talking about aerodynamic challenges, structural mechanics, battery performances, flight dynamics, etc. Towards aerodynamic modeling, how rotor works, how the airframe interaction works, how the tailwind headwinds can interact with each other, how the, if I talk about rocket systems, how the aerodynamic effect will be there. These all things we need to understand. Structural and fatigue analysis, of course, there are a lot of loads, different loads carrying capacity of different components of the systems that we need to study. Battery, nowadays we are working on battery systems, eVTOLs, etc. So definitely battery, understanding how different temperatures can have the effect on these battery, how the containment storage effects are there. Then of course electromagnetic interference, because there are a lot of communication systems present inside the aircrafts or rocket systems or eVTOLs to understand the scenarios. And then control systems and AI integration, where we are working on advanced flight control algorithms, AI-based autonomy, etc. So moving towards designing of drones, as I told you, I've taken one example of drones, and then we'll move towards the scattering one. For example, one of the challenges is with respect to the aerodynamic analysis. how the flight dynamic works, how the yaw, pitching movements, and all these works. What are the challenges and how we can come out of that. Secondly, towards the electromagnetic simulations, how radar works, how the lightning simulation happens. Then once we come towards the structural simulations, bird striking is one of the challenge. Then how if the dropping effect happens, if it's strike by something, and if the uh, eVTOL drops here, how can it be getting affected? Then wings are composites in nature, how it can happen. And then moving towards next thing is aeroacoustic or vibroacoustic, where you have design of rotors, components, how the acoustic thing will work, how the noise effects will be there, because it is all in the air that we are talking about. And then of course the efficiency, such as reducing the weight, optimizing the motors, minimizing the drags, all these things comes into picture. So these are all the challenges that industry normally inculcate when it is about the eVTOL systems. Sorry. So we have different solutions for that. For example, if I talk about the aerocausticity, or if I talk about the flow simulations, so we have a product known as Power Flow. So it's basically a solution which gives you challenges, which solve the challenges with respect to eVTOL air taxis, which solve the challenges with respect to your flow simulations, etc. Then we have another solution known as CST Studio that works on both high and low intensity radio frequencies, how to understand the entire electronic systems. Then of course many of us knows about SIMULIA Abaqus, which works on structural simulations including explicit analysis, implicit analysis, as well as co-simulations. We also have the solutions for battery packs. We have a dedicated solution where you can model your cell level to package level of batteries, where you can understand what is happening, even the chemistry part of it. So we have a solution known as BioVia for that, 1D simulations known as Dymola for that. So these all simulations are integrated. And then of course we are more concerned about the lightweighting in aerospace and defense with higher strength. So we have a tool known as Tosca, which can do topological optimizations, topographical optimizations, shape and size optimizations. And then again, aerodynamic challenges, as I told, we have Power Flow. And for motors, we also have solution known as CST Studio, Simpack, as well as Manatee, where you can design, develop, and see how your electromagnetic effects of the motors can be understood. So moving towards the first challenge, that is our aerospace composite challenge, because now the industry has already revolutionized towards composites. We are overtaking conventional metal towards composites now. So it's very basic to understand how composite works, how we can basically design and simulate composites and manufacture them. So basically we have end-to-end solution which can help you in designing, in simulating, as well as in manufacturing of these composites, because composites are very unlike metals, right? They are totally anisotropic, non-homogeneous in nature, and then they have layups effect. So you have to tell your manufacturer which layup I want to do, what kind of layup I want to understand. So like that, in earlier era, a lot of engineers used to require, like CAD designers, simulation analysts. Then it will go again to CAD designer because to have some changes, and such a things will continues, and there will be a data loss, time loss that may happen. That will definitely affect the cost, the duration, all these things. So as a company, we offer you a solution where you can have a complete designing of your composites, whether it's a complex composite structure where you can use your own layups, you can create your layup sectioning, you can design the layups, and within seconds, this entire layup section can be act as a preprocessor to your simulation tool. That is what we have known as Abaqus. And then you can also do some parametric studies, so that you are not manually changing any kind of layups. You are directly giving the command to our parametric optimization tool that I want to use this thickness or these layup changes are there. So these all things can be directly transformed, and you can do n number of iterations within few minutes of time. So then moving towards simulation. So our simulation tool gives you a probability for doing both 2D as well as 3D simulations. But another beauty is you can also do simulation of composites in both ways, that is shell as well as solid. So in many of the software, they are using surface modeling and then you are transforming into it. But here we can do both shell as well as solid modeling of composites, and you can get the ply by ply informations also. That if I want to understand that I am having 10 plies in a particular composite, what is happening in the third ply, fourth ply, you can all do that. Plus, we also have generalized theories. So, for example, von Mises stresses and all don't work for your composites. So here we have Psi-Hill criteria, Psi-Wu criteria, which gives you the actual parameters to understand the failure of the composites. So here there are two different examples. For example, if it is a 2D shell or a 3D solid, this is the way how we can basically model our composites. Shell elements are there, continuum shell elements are there. Then we can give the solid thicknesses. So all these scenarios can be very well integrated with respect to our tool. So different meshing methods are also there for composite structures. One is with respect to shell, another is with respect to continuum shell or solid. So all these things we can definitely do. Then we can visualize the plies also. For example, you are giving a orientation because it has a very good impact on how the strength is basically for what loading condition you want, what kind of strength. So it helps you understand. So you can visualize your layups as well. And then after performing your simulations, you can definitely do the parametric study. As I told you, there might be a chances your material may fail in first chance, second chance, third chance. So what you do is normally you manually change the things and then you do the simulation. It takes a lot of time. So here we have a parametric tool which you can give the change in orientations manually, and it can perform the simulations in nick of time. For example, I want 45 to change to 90 or 90 to change to minus 45, minus 45 to 30. So we'll give all the parameters to our parametric optimization tool, and based on that, it will give you the results for all these particular scenarios in a nick of time. And then you can do different iterations also based on the thicknesses, based on orientation effects. So all these things can be taken care by the tool itself. And then as I was telling you, it is not only designing and simulation of the composites, but also the manufacturing of composites. You need to make manufacturing drawings out of that. So basically simulations or designing we are doing to manufacture something, right? So that is the reason we also have a tool for manufacturing preparation. So here what we can do is we can create layups as well as your protruded views, or you can say exploded views to all these particular scenarios. And then you can generate your own designs based on the models you are having, and you can pass it on to your manufacturer. So manufacturing drawing, all 3D parameters, 2D parameters, the cut sections of each and every ply can be given to the manufacturer for that thing. So it's very safe as well as good tool to use for. So this is the entire scenario for composite preparation. That is, you will start with the preliminary design, followed by composite simulation validation, and then a detailed composite ply design, and then the manufacturing part. So we covered each and every scenario in a single environment. So as I was telling you, right now we are talking about different tools, but now what we have a unified tool known as 3D experience platform. So you might be seeing 3D VR, all has been written. So now it's not only Abaqus or CATIA. Basically, we have set of tools that can do seamless simulation in a single scenario. So I'll showcase you also a demonstration video, how it basically happens. So this is a particular scenario where you are using a 3D experience platform. You can see the GUI also. So here, if you can see on the top of side left hand corner, it is in 3D experience CATIA. So this is a CATIA, but the interference is changed. So here we are using a CATIA composite tool where you are doing all kinds of layup sectioning, simulations, and everything in a particular platform. You can see carbon fibers, cured thickness, uncured thickness, ply generations. Everything is done in this particular window. And once this pre-processing part of ply generation and everything is done, then within single clicks or few clicks, you can directly go to the simulation tool. So you can see here, now the scenario has been completely changed. Now you are in CATIA assembly design, and in a click you have reached to SIMULIA. SIMULIA is nothing but the backend works on Abaqus only, but your data is saved. It is not lost. For example, when you are making a complex geometry, right? In that case, what happens when you upload the data in form of step file, CAD file, SLDT files? So when it goes to a FES solver, what does it do? It may repair, it may have some gaps. You have to repair all these gaps. Many a times it happens. But in our 3D experience platform, what has happened is you are using the same GUI for Katia, same GUI for Simulia. Only thing is within clicks you have to transform that geometry. So there is no data loss or anything that happens here. Right now you can see the simulation has been completed, and now the scenario is in such a way that you can understand what is happening with it. And you can see here left hand side Simulia parametric design study. So now after the simulation has been completed, now we will be doing a parametric study where we are using our own parameters. For example, I want this much stress or this much thickness or this much of ply orientations I want to change. I can do all these kind of things, and within clicks I will get all the scenarios. For example, in this case, what are my maximum stresses, or whatever inputs I have taken here, I can all simulate it, and I will be understanding what happens in what scenario. Okay, so this is how entire studies can be done. And further, when we move towards the manufacturing part of it, you can see here. Now, again, you are going to CATIA composite manufacturing preparation. And here you can create your own manufacturing drawings, which can be transformed to your manufacturer. You can see here in the left hand side where your red color things are there. These are nothing but ply section. It's a cut ply sections basically. So you will be able to transform each and everything into a manufacturing drawing and pass it on to your manufacturer for it. So this is an entire scenario of composites. Now we have done about the structure. Definitely metals and all are also there in structures. You can easily do that. A lot of explicit analysis, crack propagation analysis you can do. Now we are moving towards the flow section, that is CFD part of it. So you can see here same window, but now we are moving towards Simulia fluid scenario creation. That is our tool for fluid simulations. And now there is again an example of a drone where we have given some inputs. You can see at the right hand side model physics initial. So you will be completing each and every scenario, and software will guide you what things are missing and what things you require to do more to finalize your model. So once the model is finalized and you have put your all inputs, it will automatically change to green color to showcase you, okay, everything is running in a better position. So you can create your own wind tunnels to understand what is happening with drones. You can create your own fluid scenarios, what is happening with different case studies. And one more thing, for example, if I want to understand what is happening with different angle of attack scenarios. So in that case, we have taken one case study where one angle of attack is 0, one angle of attack is 3. And now how the fluid scenario creations has happened, what is the gauge pressure in two different cases. So what you can do is you are performing two different solutions, but you can compare all these solutions in a single window as well. So for example, for 0, what is the scenario? For 3 degree of angle of attack, what is the scenario? And similarly, you can have your all contour plots as well based on the inputs or outputs what you want. And then another thing is there is a linear velocity, straight velocity input or inlet that you can give, and then you can study about the fluid, but you can also provide the conditions of yaw and rolling movements as well. So you can give the velocity direction in X, Y, Z direction so that you can understand how the yawing and rolling conditions can be simulated. Plus, you can also get the outputs in terms of drag force and lift force. So what happens here is, for example, I want to understand what is CD, CL, CM of the particular thing, or lift to drag ratio of the particular environment, how I can do. Some of the outputs may not be available in the solution. So what you can do is, you can have your own formulas, and we have a tool where you can put your own formulas, and based on these formulas, you can get the contour plots. So for example, I want to have a particular field expression. So for example, I want a CL. So I will put a CL formula, that is a coefficient of lift formula, and based on that I can get the output in terms of coefficient of lift. So these scenarios are also covered in the simulations. And another important part is where you are having the radar systems, antennas, PCB designing. These all are very complicated things which we need to understand. So our platform can also do that. So what happens here is, firstly, we have started with designing of something. Secondly, we have done simulation in a structural manner. Third, we have done simulation in a CFD manner. Now, the fourth part is we are covering the electromagnetic parts, radar parts of this particular scenario. So first case study is like how we are simulating the particular scenario. So for example, you have designed the antenna, you have prepared the 3D model of the entire aircraft, where you are placing the antennas, how the RF component works, how the design verification is taking place. So entire thing you can do it in a single software. So one of the case study is lighting simulation. So you can see experimental things are also going on. Parallelly, the simulation work is also going on. So you can also do the lightning simulation in our simulation tool, where you can have your own cables, you can have your own sources, lightning channel, and all these things, and you can get the output in terms of currents versus times, etc. And similarly, this case studies for different material. You can see aluminium, see a carbon fiber composites, again aluminum. So different scenarios has been developed here. Another things are in terms of lightning indirect effects, where you can have your local striking areas, you can decide high frequency transient analysis, then you can visualize the results in terms of that. So it works on both high frequency analysis as well as low frequency analysis. And these are the direct effects in terms of EMAG application, where you have low frequency transient EMAG application with respect to aircraft panels, and as well as you can do transient thermal analysis. And then these results can directly go into a structural simulation for understanding better in terms of compressive load analysis or any kind of bending load analysis if you want to do. Third thing is again antenna performance, how our antenna should be, what kind of rays are there, what kind of radiations can be done, how the coupling between antennas can happen. All this kind of visual understanding can be definitely be done using this particular solution. And then of course PCB is another part where avionics of the particular scenario works, how you can perform the IR drop analysis, heat transfer analysis, temperature analysis in terms of PCBs. That can also be very well simulated using the particular tool. And then this is again an important part, because a lot of things are transformed into electric motors now. So you can also do a complete analysis of electric motors, where you can also understand the magnetic part of it, as well as entire rotational effects, what all things can be covered in this particular scenario. And then of course the radar signatures to it, how the radars work, how the particular things can be computed in terms of the effects of the radars, initial effects, final effects. So all these parts can be completely understood by the tool. So here what we are proposing is that it's a single GUI, it's a role-based system. So whichever role you want or whichever situation you want, for example, a structural engineers want a structural scenario, so we can provide you that. Then CFD person wants a CFD scenario, we can provide that as well, plus the EMAG applications, the radar applications, etc. So we also have one major tool where we work on the multi-body dynamic simulations, both in a rigid as well as flexible manner. So Mr. Anand will be demonstrating on how the multi-body dynamic simulations can help you out, and then followed by that we will be taking your questions. So over to you, Anand.
Thank you, Danish. I hope I'm audible.
Yes, Anand, you're
Okay.
audible.
So this is the agenda for this Simpack. Like we will discuss what is Simpack and its applications. Then what are the benefits of SIMULIA MBS or Simpack solutions. Then we will discuss some advanced vehicle dynamics MBS processes like handling, ride, then drivability, durability, NVH, and real time. So what is Simpack? So Simpack is a multi-body simulation software used to analyze the dynamic behavior of mechanical systems that contain the multiple moving bodies connected by joints, springs, dampers, and force elements. And Simpack is used to predict and optimize motion and loading of any mechanical or mechatronic system, even up into the acoustic range. And its applications, like first is automotive. So here we can go for handling scenario, ride, and comfort scenario. Then next is engine application. So it is a complex system that has almost 100 moving parts. It includes flexible bodies also. Okay, so a lot of details are there. Then next application is railway vehicle. So Simpack is very strong in railway vehicles, and it is the first application of Simpack. So here we can go for derailment analysis, comfort analysis. We can calculate the critical speed of the railway vehicle. Then next is wind turbine, like offshore wind turbine. So we can generate the aerodynamic and hydrodynamic forces in Simpack, and we can analyze it. Then next is a roller coaster, like it is just a railway vehicle, means any type of railway vehicle, and we will check for the wheel to rail contact. Then next is a land machinery. Okay, so that land machinery also we can go, like it is important to bring the overall hydraulics, so we can also bring the hydraulics into this. And next is the general machinery. So any type of drivetrain or a drive line. So here we are seeing the flexibility of the ring, which is taken into account. Now we will discuss the what are the benefits of SIMULIA Simpack. Okay, so these are the benefits, like we will discuss versatility and efficiency, then solver speed, solver robustness, result accuracy, real-time capability, and process automation. Okay, so first benefit is versatility and efficiency. It means easily it's mainly easy and efficient model setup, and it's about the simulation process standardization, and it's also related to advanced MBS result assessments. So how it is achieved, like we have Simpack pre for the pre-processing, and for the process standardization we have Simpack wizard. Okay, we have some standard templates through which we can do this process standardization, and we have Simpack post. Okay, and why it is important? Because it provides an option to do a fast modeling turnaround times and to obtain reliable simulation results. Okay, and due to process standardization, and it allows to do a fast result and KPI assessment. So next is a solver robustness. Okay, so what does it mean? So it's mainly challenging simulation scenarios, it's mainly challenging simulation scenarios which are running reliably. For example, if you see here the animation, it's a complete vehicle model running on a huge single bump, and the lift off and touchdown effect, which is quite challenging simulation from the numerical point of view. So this is running very robust in Simpack. Okay, this means there is no time consuming solver tuning necessary for this. And okay, and it is important because this guarantees the simulation process reliability, and also a projectable results availability, which is essential for the according simulation processes. And next is result accuracy. So Simpack does not only deliver the accurate results in low frequency areas, for instance, for handling dynamics applications, but also accurate results up to the acoustic of gearbox, like a gearbox noise or other acoustic effects. Okay, also it also means that it is possible to set up the models with unreached level of the model detail. So for instance, here we can see the complete car models, and then complete truck model, and also complete engine model containing a lot of detailed components. And due to a Simpack solver capability, it is possible to get really very precise and accurate results for those kind of models. And how it is achieved? So there is important technology, which is Simpack flex body integration technology. And here again, three types of flexible bodies we can import here. Like first we can see Simpack MBS integrated reduced linear flexible bodies. It's only a linear deformation. If you want, then you can go for this. If you want a non-linear deformation, then you can go for this Simpack MBS integrated reduced non-linear flexible bodies. And there is also co-simulation between MBS and APM, like Simpack and Abaqus, we can say. Then means you can also include the plasticity here, okay, in this co-simulation. Yeah, so why it is important? Because of course it's in order to ensure to trust in and rely on the simulation, and somehow with prerequisite to minimize the need for the physical prototypes with accurate simulation results. So next benefit is the real-time capability. So this means that we can do an unreached level of the model details, enabling new simulation processes. And due to the fact that we have those detailed models also running in the real time, we now can enable processes like real-time ride simulator. As you can see in this here in this animation, real-time ride simulator is there. Okay, so one person is there sitting inside that test rig, and he is giving the input to the model which is built in the Simpack. So this model you can see here. Okay, so with the actual means physical devices like steering or acceleration, brake pad. So these physical devices he is giving input to this car which is built into Simpack. So that's what is called as a real time. And what does it mean in terms of the process simplification? So being able to use the same model for the offline and real-time application, this means there is no need for the real-time model simplification. Okay, means we can use the same model for the real-time applications. And last but not least, there is a process means automatization capability. So this means Simpack provides a coding tools and processes to do an automatic execution of standard simulation processes and also automatic assessment of the standard products KPI. And how this is achieved? So we have Simpack wizard capability like to facilitate the standardized processes. So we have standard templates here we can see, and we can select these templates and we can build the model. Also we have standard load cases templates. So we can select the load case. Okay, we have built the model and we can create the scenario. Then we can go for the results. Okay, we will run it and we will go for the post processing. Okay, so it is based on the intelligent assembly of the model hierarchy levels. So you can see here on the right side, the whole processes are based on the template based parameterized models, which can be grouped in models and sub models, and they are assembled automatically. Okay, and last but not least, Simpack provides a scripting capability for all kind of Simpack functionalities. So this starts with the model creation, goes through a solving the models and doing parameter variations up to the and the result of post processing. And why it is important? Because it allows to minimize the manual simulation process effort, and it delivers reliable simulation process and results. And therefore, it's a keeper means it is faster and better product KPI assessment and optimization. Okay, so next slide we will discuss the vehicle dynamics relevant components and systems. Okay, so there are many relevant components and systems to be considered. So this starts for the instance with combustion engine. Okay, and gearbox block unit includes the clutch flywheel converter component. It includes the flexible gear drive and flexible drive lines, and of course flexible elastic kinematic or kinematic suspension. Then steering system, and last but not least the flexible car body or subframes. So next slide we will discuss the workflows in the vehicle dynamics applications areas. Okay, so first we will start with the handling. Okay, so handling, this means it's the assessment. Next slide. So handling this means it's the assessment of the lateral vehicle dynamics and according KPIs. So typically a vehicle should be easy to drive and easy to control at a lateral dynamic stability limit, and it should be also fun to drive. For instance, dynamic steering response and steering feeling should be convenient. So in order to achieve this, it's a complete vehicle simulation in terms of open loop maneuvers like constant velocity cornering analysis scenario or fish hook, as well as closed loop maneuvers including according driver models to do a simulation scenarios like a double length change, constant radius cornering, or other simulations. And see these here we can see this automotive vehicle like a car, we can see passenger car. So it is applicable to all like passenger cars, trucks, or buses, or any like a defense vehicles also it is applicable. So we can go for that. Next workflow is the ride. Okay, so what does it mean? So it is related to the vehicle dynamics and according KPIs. So the target is convenient vertical vehicle oscillations behavior and the related occupant driving comfort perception. Okay, so in order to achieve this, using the virtual simulation scenarios, for instance, hydropulse test rig, you can see here, this is hydropulse test rig simulations. These are used including the deterministic, synthetic, stochastic, and measured road profile excitations, as well as the transfer path analysis. And another option to drive the vehicle on the virtual road, as you can see here. And in order to achieve this, there are several options to do this. For instance, the single obstacles using synthetic, stochastic, and road surfaces, and also based on the measured road surfaces. So we can also enter import here the measured road surface data. Okay, so next workflow is the drivability. And the drivability means the longitudinal dynamics and according KPIs. So the target typically should be there is a dynamic but same time convenient longitudinal acceleration and deceleration to be achieved. So how can be this assessed and optimized using the simulation? So that's basically used in the longitudinal dynamic complete vehicle maneuvers. For instance, we can do the gas pedal tip in, tip out simulation. Then idiot start, also called as a rapid start. So idiot start is basically rev up the engine and drop the clutch. So that is extremely hard simulation scenario when you do that on your car. So you are going to excite everything that can vibrate. So you need a very robust solver to solve that. And then investigate the gear shift behavior or braking behavior of the vehicle. Okay, so next workflow is the durability. Yeah, so durability is related to the mechanical component reliability and according KPIs. So for instance, these are dynamic loads and stresses, fatigue and durability results derived from the dynamic loads. And how to determine this in virtual simulation? So typically there are hydropulse simulations, then rough road simulations, or also driveline loads and oscillations, which are input for the dynamic loads. And also abuse or extreme events can be used in order to determine according loads. So for instance, maneuvers like pothole braking or even obstacle collisions between the suspension components and the and obstacle might be the simulation scenarios. So stress results means a stress result post processing is possible inside Simpack. Means we need flexible bodies for that. Means you can see the control plots like this. You will get the stress results, and we need to transfer these results into FSAP code. Okay, or the where we can go for the durability, like we can calculate the fatigue life. Okay, so next workflow is the NVH. So NVH means the mechanical structural noise and vibrations of the vehicle, and they are also according KPIs. So for instance, there is resonance frequencies and amplitudes of the forces and accelerations, and we can also determine the surface velocities or assess the acoustic pressure. And how this can be done in Simpack? So it is basically doing nonlinear powertrain and driveline effect analysis up to the acoustic range. For instance, by doing a complete vehicle driveline run-up simulation. Okay, also we have like simulation scenarios like gearbox whine and gearbox rattle analysis. So this is gearbox whine means a high pitched, smooth, continuous noise, and gearbox rattle is a more irregular, metallic or clattering noise. Okay. Then next workflow is the mechatronic experience. So this is last but not the least related to vehicle dynamics workflow. And this contains the software in the loops, hardware in the loop, and main in the loop simulation scenarios. Okay, this is also called as a real-time capability. So this mechatronic experience relates to a convenient overall mechatronic system experience. Like especially it's important to enable simulation based on development of the advanced driver assistance systems, for instance, for the autonomous driving. And how can this be enabled? So there are several technologies like hardware in the loop, software in the loop, or man in the loop simulation. Okay, so man in the loop simulation, here we can see this is the test rig for the man in the loop simulation. Means that person which is sitting inside the test rig, he is giving in the input to the car which is built in the Simpack, okay, by physical devices. So this is achieved by this HIL, SIL, or MIL, like man in the loop simulation. Okay, so in next slide. So in order to summarize the vehicle dynamics workflow, again, this slide show there are several workflows related to the vehicle dynamics, and it's important to note that almost all of them are also able to be performed in the real time. Next slide. Due to this Simpack solver capability, we can see here handling, ride, and mechatronic experience drivability. It can be done in the real time, and these two can be done in the offline. Okay, so next slide. And only one only one MBS model is required for the all vehicle dynamics applications. Okay, for all vehicles. So next slide, last. So now, okay, now is a conclusion. So regarding complexity, Simpack helps to cope with increasing systems complexities because Simpack innovates and provides a unique MBS simulation technologies. So in terms of diversity, Simpack allows to efficiently simulate and assess many variants because Simpack contains a sophisticated solution for MBS processes, standardization and automation. And Simpack also facilitates fast development times and at a minimum cost because Simpack is the best available fast, robust, and accurate MBS solver. Okay, so that's it from my side.
So yeah, first of all, I would like to thank Dr. Ganesh and Anand for delivering a very insightful presentation. I think it was very useful to our customers as well and to the audience as well. I would like to also thank the audience for taking their time out and attending our session today. If you have any questions related to the subject matter or any other simulation requirements or multi-body simulation requirements, you can always reach out to us. Our contacts are displayed on the screen right now. You can either mail us or call us, and we'll be happy to address your queries. So once again, I thank Dr. Danish, Anand, and our audience for this session. Please do keep an eye out for our upcoming webinars and seminars. You can follow us on our social media for the same. Thank you once again.